Right now, a whisper of light is landing on a mirror a million miles from Earth. It left its source more than 13 billion years ago, when the universe was barely a newborn. The thing that sent it is enormous, blazing, impossibly old. It is not a nearby galaxy. It is not the glare of a black hole. It was already ancient before the atoms in our sun existed. That light comes from just 300 million years after the Big Bang, 2% of the universe's whole life, the first week of a human lifetime. And when the scientists finally measured it, the word one of them reached for was stunning. Another called it the archetype. This is the story of what the James Webb Space Telescope found when it looked farther back than anything ever had, and why the picture it sent home does not match the one we predicted, not for the model in every textbook, not for the men and women who built it. Stay with me, because this is not a story about a broken universe. If you grew up watching us reach into space, and you want the real story behind the headline instead of the hype, take 1 second and subscribe. It genuinely helps a channel like this one keep going. Because the picture we had was beautiful, and for decades it worked almost perfectly. We called it the Standard Model, a universe run by dark matter and dark energy, assembled patiently across the back half of the 20th century by thousands of careful people. Picture one of them. A young astronomer in the early 90s, coffee going cold at her elbow, watching a slow computer paint the infant cosmos onto a screen 1 grain at a time, frost spreading across a window pane. That was the expectation, and it was a modest one. Galaxies were supposed to build slowly. Small clumps first, pulled together by gravity, merging over billions of years into the giants we see around us today. Astronomers had a name for it: hierarchical assembly. Little things first, big things much, much later. There was nothing reckless in that idea. It matched the data we had. It matched the sky the Hubble telescope showed us. For an entire generation of scientists, that slow, orderly universe was not just a theory they defended, it was the water they swam in. So when Webb finally opened its eye on that same early universe, everyone expected it to simply confirm what we already knew. It did not. The first deep images came down in 2022, and almost at once the surprises started. Bright galaxies, glowing where the model said there should be almost nothing at all, and it has not stopped since. The candidates climbed fast. First galaxies at a distance we measure as redshift 10, then 12. Then the spectrographs confirmed 1 past 13, farther than anything before it. Each step reached deeper into a time the universe was supposed to be dark and empty. Then came the one that became the poster child, JADE's GSZ 14-0. Confirmed at redshift 14.32, seen as it was just 300 million years after everything began. And it is not small. It stretches more than 1,600 light-years across, far too large to be the glare of a feeding black hole, which means the light has to come from real stars. Enormous numbers of them, already burning, already assembled, in a universe that had barely started. The model predicted a faint, nearly empty dawn. Webb delivered a crowded one, more than 10 times as many bright early galaxies as anyone's math allowed. But to feel why that one number, 300 million years, is so hard to swallow, you have to understand what a galaxy really is on the clock of the cosmos. Think of it as reading a postmark. When light travels across an expanding universe, its waves get stretched, pulled longer, shifted toward the red end of the spectrum. The farther the light has come, the more stretched it arrives, and astronomers call that stretch redshift. It is their tape measure for both distance and time. Here is the way to feel it. Imagine mailing a letter across an ocean that widens the whole way. The longer the journey, the more the ink fades toward a single color. Measure exactly how faded it is, and you can tell not just how far it traveled, but how long ago it was sent. So when Webb reads a redshift of 14.32, it is reading a postmark from 13.5 billion years back. Now hold that against what a galaxy actually is. 100 million stars, gathered and lit. Building something like that takes time, the way a forest takes time. Seeds, then saplings, then the slow closing of a canopy. What Webb found was a mature forest standing where the seeds should have only just touched the soil. And with that clock in mind, the measurements stopped looking merely surprising. they started looking impossible. Impossible, and not by a little. The models were not off by some rounding error. They were off by a factor of 10. The first real alarm came in 2023. A team led by Ivo Lebay reported a set of red massive galaxies from roughly 600 million years after the Big Bang, with more than 10 billion suns worth of stars packed inside each one. That is our own Milky Way's worth of mass, assembled in a fraction of the time it should have taken. And the astronomer Mike Boylan-Colchin did the arithmetic that made everyone go quiet. There may not have been enough ordinary matter inside those young structures to build such galaxies at all, not without bending the rules the universe was thought to obey. Say that plainly. Some researchers looked at the numbers and said the models were wrong, not the telescope, not the measurement, the theory. So the field split, right down the middle, into two uncomfortable choices. Either the early universe built stars far faster and far more efficiently than any model had ever allowed, or something about the early universe itself, its physics, its very ingredients, was different from what we had always assumed. But here is the part of this that stops being abstract and starts being personal. Because the Standard Model is not just a story about faraway galaxies, it is the same framework that tells us how old the universe is, the same one that dates the stars, that sits in every science textbook a grandchild opens this year. It is a single connected structure. And if the very first chapter is written wrong, the quiet, uncomfortable question is how much of the rest we can still lean on, not because the whole thing falls down, it doesn't, but because certainty itself now has a hairline crack running through it. Many of you watched this model become settled truth inside your own lifetime. You were taught it. Some of you taught it to others. You trusted it, the way you trust a tool that has never once failed you on the job. And now the very telescope your generation made possible is asking you to hold that trust a little more loosely. We do not yet know exactly what that means, but the fact that we now have to ask the question at all is itself a shift in how we understand our own certainty. So hundreds of scientists went back to their desks, not to defend the model, but to cross-examine it. Think of it as a courtroom. The charge: the early universe built its galaxies far too fast, and the defense called its witnesses. The first questioned the measurement itself. A team turning Webb's mid-infrared instrument, an eye tuned to longer, cooler wavelengths, went back and reweighed those early giants, and they found the original masses had been overestimated by something like a factor of 2.5. Measure the light more carefully, and the impossible galaxies shrink toward the merely surprising. The second witness raised a quieter doubt: cosmic variance. A handful of giants found in one tiny patch of sky proves very little. The way one unusually tall family on one short street tells you nothing certain about a whole country. The third kept the Standard Model exactly as it was and simply asked, what if those first galaxies turned gas into stars more efficiently than we assumed? Not impossibly, just vigorously. One careful survey of 36 massive galaxies found no fatal contradiction at all, only a few extreme cases straining the limits, and then the prosecution stood back up, because the record keeps breaking. A newer object, catalogued MEMZ14, reached back even farther than the archetype had. And the scientist who found it said he would not be surprised to find galaxies earlier still. So the crisis softened, but it did not vanish. Because one thing Webb keeps doing has no easy defense at all. It is not that the telescope found a single impossible galaxy, it is that it keeps finding them, deeper and deeper, with no floor in sight. Listen to what one of the lead scientists, Brant Robertson, pointed out about the archetype. Webb could have spotted that galaxy even if it had been 10 times fainter, which means there are almost certainly galaxies still earlier, waiting in the dark, reaching back perhaps into the universe's first 200 million years. We are now staring into a stretch of cosmic history that no theory was ever really built to describe in detail, watching structure appear at the very edge of what the word early can even mean. And there is exactly one instrument, on or off this planet, that can see that far. One. When Webb's fuel finally runs out, this window narrows for a generation. Sit inside the scale of it for a moment. Light that left before the Earth, before the Sun, before nearly every atom of gold in a wedding ring was forged in a dying star. Arriving now, on a mirror built by human hands, carrying a question we cannot yet answer. which brings us back to where all of this actually stands tonight, in 2026. And where it stands is honest and unfinished. The impossible galaxy crisis has cooled from an emergency into a hard, open problem. The Standard Model is bent. It is not broken. It survived the first cross-examination, but the early universe still looks more crowded, more vigorous, more grown-up than anyone predicted, and no single answer has won the room. The live possibilities sit on the table, side by side. Maybe the very first stars formed in a way that made those early galaxies shine far brighter than their mass alone should allow. Maybe star formation was simply more efficient than the models let it be. Or maybe, and this is the one that would rewrite the textbooks, something in the early universe's physics, some brief early push of dark energy, was genuinely different. The teams are cautious. They are not making promises. But they are still looking, and Webb is still returning data, and every fresh patch of sky is another page of testimony read into the record. What is being lost is the comfortable certainty. What is still being chased is the honest answer. And when you step back from the argument itself, there is something inside it worth holding on to. The thing that outlasts any single model is the willingness to be corrected by the evidence. Sit with who is actually doing the correcting here. The people who built the old picture are the same people cheering as the new telescope strains it, because they were never really in love with being right. They were in love with finding out. That is the durable thing. Theories grow old and get replaced, the way we all do. Instruments run down and fall silent. But the habit of looking honestly at what the universe actually shows us, instead of what we hoped it would show, that gets handed down. Generation to generation, like a good tool worn smooth by working hands. A universe that refuses to match our prediction is not a failure of ours. It is the universe keeping its oldest promise, to be stranger and larger than we are. So here is what I want you to take away from all of this. Webb did not break the universe. It caught us assuming we had finished a story that had barely begun. Think of the contrast. A picture built across decades by thousands of patient people, revised in a single afternoon by a machine the size of a tennis court, 1,000,000 miles from home. The courage was never in being right. It was in wanting the truth more than the comfort. And this is being argued out right now, in data no one has finished reading. One mirror, 13 billion years of light. One question we are not done asking, so let me leave you with this. What else are we still sure of, that the next clear look will change? If you want to be here when the answer comes, subscribe and turn on notifications. Then tell me in the comments where you were when you first understood how big the universe really is. And send this to someone who taught you to look up.